Positrons are the positively charged antimatter complements of the negative electrons that clothe the atoms of ordinary matter. In our world, positrons typically have a short lifetime because they are annihilated upon contact with electrons to produce energetic X-rays known as gamma-ray photons. While beams of electrons find countless uses, for example in TV sets and electron microscopes, the positrons naturally emitted in the decay of radioactive isotopes such as sodium-22 are too energetic to use without slowing them down first. A typical positron beam apparatus has a heavily shielded region containing a sodium-22 source next to a solid that spontaneously ejects a few percent of the positrons at low energies. Though weak compared to the electron beam of a TV set, the UCR positron beam of several million slow positrons every second is sufficient to encode a surprisingly large amount of data. An amusing illustration of this is afforded by amplitude modulating the positron beam intensity using the signal output from an audio compact disc player. The modulated positron beam is annihilated upon contact with a target, thus forming an amplitude-modulated gamma-ray broadcast signal analogous to the familiar AM radio signal, but at 1 trillion times higher frequency. The gamma rays detected several inches away from the target are converted into an audio signal that is a bit noisy, but clearly allows us to identify the composer. The important point is that vastly improved microscope images, materials measurements, and novel devices making use of antimatter will soon become practical.
In the near future, I'm intending, with the help of my students and especially my postdoc David Cassidy, to make positronium molecules. We're going to make large pulses of positrons, focus them down to a tiny spot on a piece of metal, at which point they will recombine with electrons to make dipositronium molecules. That's 2 positrons and 2 electrons will be stuck together. This will be the first time that anybody's been able to make a more than 1 positronium system, atomic system.
These positrons may then be transported to a positron microscope that can show us what something looks like when illuminated with antimatter. The UCR positron beam will be used to collect and store up millions of positrons that will be unleashed suddenly to form a small amount of diatomic positronium, which will be the first molecules composed of equal amounts of matter and antimatter. Later experiments will attempt to form superfluid liquid positronium, a central component for an annihilation gamma-ray laser that would be useful for metrology and munitions.